Hello, everybody. Hi. All right. That's a lively crowd today, so let's make sure my clicker works. Perfect. So hello again. My name is Eitan Marder-Eppstein, and I lead the developer engineering and relations team for Project Tango. And today, I'd like to share a bit about our project, as well as where we're going for the future. But before I do that, I normally start off the presentation just by show of hands. How many of you have heard of Project Tango before? Whoa, this is probably the best response that I've gotten to that. I would say 3/4 of you raised your hand. So for those of you who don't know what Project Tango is, hopefully this will serve as a nice overview. And for those of you who do know about the project, hopefully it shows kind of the progress we've made as well as where we're going for the future. All right. So at a fundamental level, Project Tango stems from the observation that today, interactions with our phones really end at the square box of the screen. And whether you're at home browsing the internet for a new appliance for your kitchen, or at work planning for a project that you're going to build, or out at dinner socializing with your friends at a table, your phone is with you, but it really lacks an understanding of your environment. You're limited by the boundaries of the screen. And what Project Tango hopes to do is to break this boundary and to bring your phone and the world more in tune with each other. So we want to teach phones to see and understand their environments. And we would like to augment and improve our own ability to answer questions about the world around us. Those questions might be things like, how much paint do I need for a wall in my room if I'm going to be repainting my house? Or will the couch I'm going to buy online actually fit in my room? I recently bought a sleeper sofa and made a big mistake. Or how do I get from where I am to the laundry detergent in a store? So Project Tango allows us to answer these questions and more, and we use special cameras and inertial sensors that we've built into phones to make sense of the world much like we do. And we allow the phone to build a human-scale understanding of space and motion. And then we expose this understanding to application developers by adding 3 core technologies to mobile devices. And I'll talk about each of them a little bit here. So the first one is motion tracking, the second is area learning, and the third is depth perception. Motion tracking allows Tango devices to track their position and orientation in space. As the phone is moved through the environment, it keeps a log of its trajectory to within centimeters. This works almost like a mouse, but in full 6 degrees of freedom. Area learning allows Project Tango devices to recognize where they've been before. When a distinctive visual landmark, like a sign or a poster or a picture, is seen, the device stores this in its memory. And the next time it or any other Project Tango device sees this visual fingerprint of sorts, the device recognizes its precise location in the world. So I could walk into a store and recognize that I'm at the checkout register just by seeing a sign above the cashier. And the third technology that we expose is depth perception. And this allows Project Tango devices to see the world in 3 dimensions. And we've done this by adding additional sensors, special depth cameras, to mobile phones. This allows your phone to understand the full geometric structure and also the scale, the metric scale of your environment. So to give a more concrete idea about what this technology enables, it's nice to talk about it, but what I'm going to do is show a video giving an overview of the technology that we've built, and then I'm also going to show a couple of live demos on stage, just to give you a feel for what this enables. So I'll play the video now and then do demos right after that. Okay. So, as you saw, I think that's some pretty powerful and cool stuff. But there's still nothing like seeing it in action. We don't have a ton of time today, but I'd like to run through at least a couple of demos to give you a better sense of the types of applications that we're building on top of this technology. I will also be available after this session at office hours. And just a little plug, if you come, I'll let you play with the device yourself so you can handle it. So to start off with, I always like to give insight. Can we switch to the device, by the way? Whoever. Oh, awesome. All right, so to start off with, I always like to give a little bit of insight into what is actually going on under the hood. So here you see an image from a wide-angle camera that is mounted on the back of the device. And you'll see a bunch of colored dots in the world, as well as some plots on the screen. And the colored dots are visual features that we're tracking across frames. So we're looking for points that are on corners or anywhere where there's a change in contrast. And we're actually tracking that in our video feed and fusing the data together with information from the accelerometers and gyroscopes on the device, so the inertial sensors. And here, as I rotate, you're probably used to seeing that even just from a gyroscope, but I can actually start walking around the space, assuming my cable doesn't let me down. And I can return, to roughly where I was before. So the device understands how I've moved through the environment. Now, we've also got a depth sensor on the device, which allows us to see the world in 3D. So when we combine the ability to track the device's position as you move through space with the ability of it to see in 3 dimensions, this stage is mostly green, but we'll try and build a little bit of a model. Maybe I can get some of you all in the front. So as I move around the world, you can see that very quickly I'm able to gain a pretty nice geometric understanding of my environment. And this is powerful. This ties your device to the physical world. And when you have this relationship, you can start building applications that before were not possible. So one example of an application is, say I want to take a basic measurement on this wall. So I can measure, that's 0.8 meters, but you're noticing that it's not just a single frame. I can walk around the environment, I can walk up to the front of the stage, and I can produce measurements that are tied to the space that I'm in through the frame of the device moving around. Other things that I can do, say I was interested in hanging a picture here, and I wanted to know roughly the size of the wall. I can also measure area. So you can do things very, very quickly that would take time otherwise. I can also do things like measure through walls. If I wanted to drill through a wall, you can place a point, walk through to the other room, and place another point. I almost want to go backstage to do it, but I feel like that might be a bad idea. So this is really powerful. You're augmenting your world, and you're answering questions that we as humans have trouble with through the device. Other applications that you can use leveraging this same technology involve being able to shop for furniture or for other household items online in a much more practical way. So I referenced before that I really screwed up my sofa, but now I can drag items into the world. I can look at them from different perspectives. I can get right up close. If I want to, I can change the color. And the beauty of this is that this chair is at scale. So if it fits in my room, I know that I'm okay. I can also drag another chair here and align it. I think it should snap. Well, all right. Having trouble snapping. But I can place furniture in my space very, very easily and see how it actually looks. And this application was a partnership, actually, with Elemental Studio, who did the application design, and Lowe's, who now advertises that if you need a new fridge, you can check it out in this application. All right, so that's a practical use of the technology, but we also believe that this technology has the power to unlock our imaginations and to allow us to have a little bit of fun. So this stage was made for this demo, I swear. It's just so this is Mittens. He's a cat, but virtual. And you can see that I can go up to him, and he knows where I am, and he'll paw the device. But then other things that Mittens can do, he'll follow me kind of around the world, is that Mittens understands the geometry of the environment. So he can actually jump onto this surface because we have an underlying model of what the surface looks like. And when you take augmented reality and mix it with the ability to understand the geometry of the world, it becomes much, much more powerful. So you can change Mittens to Rufus, or to Gray the cat, who has really big eyes. And they can follow you, around the space, and they'll walk with you as you move. And then the last kind of fun application that I'll show, it's another game that I will challenge folks to beat me at during office hours, is Shell Games at one of our workshops decided that Jenga was a really, really annoying game to play normally, I guess. You have to stack the blocks, they fall down, you have to restack them. It's not so much fun. So they made virtual Jenga. You can see that it's sort of on this surface, and I can take a block and I can move it to the top and stack it. And it's supposed to be a two-player game, but I guess I'm gonna win no matter what. And you can see that it's a very natural interaction where you're using the device as a 6-degree of freedom controller interacting with a virtual object tied to the real space. And then this is not going to go well. Okay, so I lost Jenga to myself, but now I don't have to clean up. So if I wanted to, I could just restart the application, hold tight for a second, and have my tower rebuilt in front of me. All right, so can we switch back to the main screen? So those are all of the demos that I have for you today. But I hope, clicker, oh, this went backwards. Seconds. Okay. Those are all the demos that I'm going to show for you today. But I hope it gave an idea of the kinds of applications that can be built on top of this technology and the power of it. All of the demos that I showed are currently running on our development kit hardware. But this has actually been a progression for us. So it's taken many iterations of hardware and software to get to a platform stable enough to build these apps and to have them work reliably. And we are starting now to partner with OEMs and chipset manufacturers to bring this technology to the masses. This is no longer us playing around. And in fact, at CES last week, we announced the world's first Project Tango smartphone. So Google, in collaboration with Lenovo, is going to build a smartphone that will launch in the summer of 2016. It'll have mainstream price points under $500, and it will launch globally, including in the US. And we know that with a launch of this size and scale, just putting the device out there isn't enough. We really need to have applications and compelling use cases to make this product a success. And to build them, we're looking for help. So we're looking to partner with developers in the space. And to this end, we've launched what we're calling the App Incubator program for Project Tango. This is, again, a collaboration between Google and Lenovo. And through this program, we're looking for developers and studios who are passionate about the technology, who are passionate about the space, and who have ideas about what they could build on top of this platform. And then Google and Lenovo will work with these companies to provide funding, to provide support, and to help make your vision and your dream of what you could do with an application and platform like this a reality. There will be opportunities to be featured on the device as it launches, and Lenovo has also stated a desire to have some of these apps be pre-installed on the device, opening up the market that will be exposed to your technology. And we are accepting proposals for applications through February 15th of 2016. So we're looking to make decisions as to what applications we fund in the relatively near future. You can go to google.com/Project Tango and you'll find more information on applying for the program. So if you have an idea that you're passionate about for this platform, we really, really want to hear from you. We know that this can't happen without creative input, and we know that we don't have all of the great ideas that could be built on top of this platform. I'll conclude by just saying that we have APIs for C, for Java, and we have a tight integration with Unity. And we are also working on an integration with Unreal as well. So if you use any of those programming platforms for Android, Tango should be relatively easy to pick up. I want to leave some time for questions, so I'll take those now. I think I've been told there are mics up front and one in the top, so I'll take questions. Yes?
How accurate is that IR sensor in Tango? Right? Is it kind of like pumping inside walls and like a hotspot to electric box, or is it not like really accurate?
So the question was, how accurate is the IR sensor? So you don't get direct access to the infrared camera with Tango. I can talk about the accuracy of depth, but as far as seeing through walls, that's something that's a little bit hard to do. But the depth is accurate to about 3% over the distance that you measure. Does that make sense? Yep. Okay. Yes?
So how does it deal with wacky lighting and crazy shadows, like shadows behind?
Yeah. So the question was, how does Tango deal with wacky lighting or crazy shadows or changes in the environment? I think you saw in the video Tango working in the presence of a lot of people that were all moving around. And the device has the capability to recognize what are sort of dynamic obstacles in the scene versus static. And as long as it can see some points that it can track over time, it's able to keep its position. Yeah, so if you move in front of the Tango device, you'll actually see the points on you in that display I showed, they'll turn red. And what that means is, hey, like that is not a thing that I should be basing. Yes, yeah. And then for lighting, the camera changes its exposure based on the lighting to try and maximize the ability to track. And that's the other reason we have that wide angle camera, right? We want to see as much of the world as possible. Because if you take a narrow angle camera and you walk really close to that wall, you'll just see white. But the wide angle gives us a very wide field of view of the world and helps the robustness of our system. You, in the, yes, jacket, yeah, you put your hand down. Yeah. So the question was, we assume that all the processing is happening on the device, which is correct. All of the processing is happening on the device. And how easy is it to develop a simple app? So there, getting up and running with Tango is very, very easy. In Unity, it takes less than 10 minutes to have a basic motion controlled camera in a virtual scene. In C and Java, maybe up that to 30 minutes to an hour just to get everything set up. And developers.google.com/Project Tango has all of the entry points for our tutorials. And I'm also very happy to talk about that at office hours as well. You standing in the back, yeah.
So does Google or any of its partners have plans for, say, a planetary scale SLAM geospatial database? Sort of like an Instagram for Tango?
So the question was, does Google have plans to, I guess, map the world with Tango? So at Google, we're always interested in mapping the world. We do think that this technology has a lot of potential for indoor navigation. So we've started with some trials where you go to a mall and you turn on the device and you can do things like get directed to a store with turn-by-turn directions. I know I could have used this at CES last week, actually. Vegas is not good for indoor navigation. And you can also do things like try and find your friends because you have a shared coordinate frame. So it's an exploration that we're beginning. We do think location-based experiences and navigation experiences are sort of one of the pillars that we'll explore for this technology.
So no Google Maps integration out of the box?
I cannot comment about Google Maps integration. Yeah. Yeah.
Is there any compatibility between Project Tango and Intelligent Assistant?
Yes. So Intel has announced the availability of developer kits that run Project Tango integrated with their RealSense cameras. And I believe they're $399. So you can today go and pre-order an Intel RealSense device that has Project Tango capabilities. And we're working with them as well as our other chipset partners. Other questions? You in the front row in the back.
Yeah. Do you see a future with Project Tango and gaming with like Google Cardboard, for example, virtual headset, all that HMD?
Yeah, so I think the question was, do you see a future for Project Tango with gaming? And I think that there is a huge future for Project Tango with gaming. I think there's also a huge future for using Project Tango for any kind of positional tracking. And you can think about extensions to that. We've played around with taking it and putting it in an HMD. There are other problems with that, like screen refresh latency and all of the problems that sort of come along with that. But I do think that people will use the devices in that way, and it's really interesting to me. Yes?
I haven't used that device, but will outdoor Lake Tahoe with lots of overwhelming?
The question was, will Project Tango work outdoors? And the answer there is that pieces of the stack will work outdoors. So the motion tracking and area learning capabilities will work outdoors, but depth perception, trees and leaves are actually great features to track as you move through the world, but the problem is the sun. The sun turns out to be a really, really strong source of infrared light, and so for the depth sensors that are currently on the Tango tablet, they get overpowered by the sun. So you would be able to do outdoor navigation with the Tango device, but having Mittens follow you through the trees, unless you were in a shaded area, would be difficult. Well, I think the problem with using specialized lenses to filter out IR, which is something that you can do, is that the device needs to see the IR pattern to be able to do its depth computation. And so if you filter out that IR, the device doesn't see the pattern. There are solutions to this. Yes, it depends on the sensors. The current sensors, no, but over time, we hope to improve the ability of these devices to see outdoors. Other questions? Yes, you next to the blue, yeah. So the question is, can you share the 3D models that you create of an environment? Right now, the constructor application that I showed you will export to OBJ and PLY files, which are just standard mesh assets. You have to give permission to export, like the user has to click a button, but once you have the file, you're free to email it or do whatever. And you could import it into another Project Tango device's memory space and use it if you were so inclined. Yes? So the question was, will Tango technology be extended into other form factors like robotics? I think absolutely yes. Well, I hope so. My background's actually in robotics, so I have a little bit of an interest in this. But we've already had interest from people who are doing quad rotors, anyone who needs a lightweight localization solution on their device. I think there's huge impact potential there. We're really focusing on the smartphone space first to drive down the cost of these sensors and to make the technology more ubiquitous. We believe that that's the best way to get it out into the world, and then things like robotics can piggyback on top of it. All right. I am out of time, but I will have office hours right after this. So thank you very, very much for your time. Enjoy this.